Well, this is going to be about Newton's method, and I'm going to try to jam two examples and an explanation into one video, if possible. Now, I know I already covered Newton's method in class, but it bears repeating. The formula is here. Whoops, let me make this draw. The formula is here, but we're going to develop it rather rapidly. So we got the x-axis. We have a curve running through space, call it f, and we are looking to see where it crosses. We're looking for the zero here. Okay, and so what Newton's method says is choose a seed or a place to start, call it x1, and then cruise up to the curve and find the equation of the tangent line. And when you do that, set it equal to 0 and find the intercept of the tangent line, not the curve. But when you do that, we'll label that x2, but you can see we're getting kind of closer. Next, Newton would say, why don't you cruise down and do it again? I'll do it in another color so we don't get dizzy. Okay, so this guy will do the tangent line again, and it's almost it's microscopic. You can tell that the intuition was, hey, if I keep doing this, I get closer and closer to the 0. And what's happening on the number line is you've got the actual 0, whatever it is here. You start with x1, and then you do the tangent line. You end up with x2. Do the tangent line again. Now you're at x3, and the idea is you march closer and closer. So basically, we're going to take the equation of the tangent line, let's say, at the first point, and the point is, say, x1 and then f of x1. Okay, and we're going to set it equal to 0 and solve for x, and that's going to be our next guy, x2. So the way that looks when you develop it is, well, the equation looks something like this. Y minus f of x1, that's y minus y1, is equal to the slope, f prime of x1, okay, and then x minus x1 looks like that. I'm going to not dizzy you with the algebra here, but when you solve for x in all of this, oh, no, wrong. What we do is we set y equal to 0 so that we can find where the line crosses the x-axis, okay? So then when you solve, you've got like I'll do it, f of x1 divide, I'm going to bring this guy over, divide him under, f prime. You see what's happening is the formula is forming before our very eyes. So we end up with x, or x2 if you will, is equal to x1 minus f of x1 divided by f prime of x1. And in general, the next term in the sequence of x's approaching the 0 is found by taking the previous number, subtracting from it the function at that value in the numerator divided by its derivative. It's just the way it works out, and this is Newton's method, okay? When I'm computing this, you'll see what I do in the next example. So I have a way of just doing it in this tiny little TI-30X calculator. It works like a charm. So let me show you. First of all, the problems you see, the first couple will say, here's a function, and use the seed value and mess around. But these two examples are actually farther in the section where he goes, use Newton's method, which we know to be xn plus 1, it bears repeating, xn minus f xn over f prime of xn, woo, new formula. Use that method to approximate the fourth root of 600. That seems like, oh, wait a minute, we should do linearization or something. Yeah, you could. And it's similar to that, but this is linearization gone amok. It's like do it again and again until you get as close as you want to go. But what's the function? Here's the thing, here's the trick. You're trying to find the fourth root of 600, okay? And I don't know what it is. So what we do in algebra is I put a big fat X there, and I'm trying to solve this equation, okay? Well, the next move might be 600 is equal to x to the fourth. And then if I do the following, let's see if you like this one, x to the fourth minus 600 is 0. So I throw the 600 over with the x to the fourth, subtract it. So in other words, that when x to the fourth, your unknown number x is taken to the fourth power, and you subtract 600, you get identically 0. That's the same thing as finding the fourth root. Isn't that cute? And you know what? That's going to be our f of x. Okay. So, well, we've got our f of x, which is cool. And by the way, the formula says we need f prime, so let's find it right now. F prime of x is 4x cubed. Okay, he's ready to go. And the only question is, what's our first seed? Where should we start? Okay, well, where do we think a 0 is? So what I did is, I'm a little heady on this problem, but what I did is I go, well, let's guess at the answer. 2 to the fourth is 16. No way is 2 the fourth root of 600. You know what I'm saying? So I'm trying to find the answer. 3 to the fourth is 81. 4 to the fourth, at this point I have to admit I took out a calculator, 256. 5 to the fourth is 625. And you can see, look what happened. We passed 600, didn't we? And you know what? 600 is close to 625. It's closer to 625. So guess what my seed's going to be? 5. I'm going to use 5. Okay? And so, all right, let's do this thing. Here's how I do it on a calculator. So on the calculator, I'm going to do it on both of these guys. What I do is I just go 5 and then I hit enter. And of course the screen says, okay, 5. But then, now here comes our formula. It's going to be, for us, it's going to be xn plus 1. Let me write it out, is equal to xn minus f of xn. For us, that means xn to the fourth, this guy, minus 600. And downstairs is going to be 4xn to the third. So that's the formula for finding these guys. So for me, I'm just going to go, I'm going to take my calculator and go, since I already put 5 in the calculator, I'm going to go shift and hit answer. Minus, and then I'm going to use parentheses. I'm going to go answer up caret 4 minus 600, divide parentheses 4 times answer, I think, to the third. So that's an up caret right there. Okay. And I hit enter. And this will play our x2 because x1 I put in 5 already. When I did that, what I got was I think it was roughly 4.95. But the beauty of it is all you have to do is shift, hit that one up arrow button or whatever the heck it is. It's the, you have those, you know how you can, you have a button that says, hey, you want to repeat that? Sure. I hit it again and you repeat, this thing happens again, but with a new answer, 495. And I got a 4.949. So x3, I hope you follow that, 4.949, because if you don't, you really want to. 232,183. 232,183. We're looking for the root now, remember. I just go up and hit it, enter again. So I do this and I hit enter. That's what I'm doing. And what it does is it displays this again. And I hit it and I got that number. Then I hit it, I do it again, and this time I got 4.949,232. Look at that, 4.949,232, and in this case it was 004, okay? Then I do it one more time, and guess what? I get the same answer again. I get the same answer. So what that means is this is as good as we can get. So we'll say that the fourth root of 600 is approximately 4.4. In fact, I bet we're absolutely accurate. If you were to do it on a calculator, this is what you would get. Okay? That's a good example. To really kind of enforce it and waste more time on this video, and of course you can pause it, do one more. This time it's an equation. Okay? What I did with this is I knew what I was going to do. I was going to do the same thing. I was going to do something like, well, I'm going to let that radical go to the other side and maybe do this. And I'm looking to see where that's equal to 0. But before I did that, I tried different numbers. I just said, well, on this side is x plus 1 square rooted. On this side is x squared minus x. And so I tried, what if x equals 1? I'm looking to see where they're equal. Well, that would be radical 2 is equal to 0. What if x is equal to 2? Well, that would be radical 3 is equal to 4 minus 2 is 2. And you know what? This guy's 1.7, this guy's 2. It's kind of close. So that's going to be my seed. That's going to be my seed. I'm just going to go x1 is equal to 2. I'll start there. But remember, we need f prime as well. So we're going for f prime. 2x minus 1 over 2 radical x plus 1. And I'm ready to go, man. I'm going to go hit 2 and hit enter. And it gives you 2. And then I'm going to hit, I'm going to type this all in. And what I typed in was the whole thing. I went answer minus 1, right? Uh-oh. Is that right? No. Answer, I'm looking at the wrong spot. Minus, and then you put the top equation. So I'm going to go answer squared minus answer minus square root of answer, believe it or not, plus 1. And downstairs, I'm going to put, oh, I should have shown you this. I should have shown you this. The way it looks on a calculator, right? So the way it looks on a calculator is it goes, oh, I'm going to do the numerator. So I'm going to go answer squared. So I hit the square button and it does it for you. Then we'll go minus answer, minus, and then I hit the square root and it does this number, right? Okay, it does this and it gives you a parentheses. And then I just go answer plus 1, close that, close the numerator, divide, and then it's worth it though. 2 times answer minus 1 divide parentheses 2 square root, and then answer what? Plus 1, close the parentheses, close the denominator of that guy, close the other denominator. So I really have 3 of them here. So plus this, and I hit enter. Okay. So I'm really kind of telling you how mechanically I do that. When I do that, I got x2 became 1.9117, 4073. And of course, I hit that thing again, and I hit enter, and I get the same readout, this guy again, and I hit okay, run it again, and I get x3 turned out to be 1.89718, 1.89718, 5923, 5923. And then I did it again, and I got 1.897, 179,401, 179,401. And hit it again just to be sure, and guess what? It was the same thing again. So that tells me, ladies and gentlemen, that's the solution. It's the solution to the equation, which was the square root of x plus 1 is equal to x squared minus x. Okay. I think what I did on this one is I actually, to even do more research, I go, well, you know, let's see, I had like, I kind of graphed it. X plus 1 means you shift this way, I guess, and this guy is going to be a parabola that's opening, what, 0 and 1 or something like that. Gee whiz. I'm not sure what I did. I think there's only one solution, but there might be two. I got to be careful what I say here. But that is Newton's method. That's how it's done. It's pretty quick stuff. Enjoy.